Hello and welcome back. So yesterday we looked at two different types of polynomial division. We looked at how to divide by separating a fraction and how to divide using long division. There is a third method we're going to deal with today called synthetic division. This method, by the time we get good at it, will go a lot faster than long division, but it is a little limited in the types of problems that we can apply it to. So in your notes, we're on page 25. Synthetic division, this method I'm about to show you, will be much quicker than long division. It is quicker than long division. However, this method is only going to work when we divide by a very specific type of a polynomial. But this method only works when dividing by a. I'll write this down, then I'll talk you through it. When we're dividing by a linear binomial with a leading coefficient of 1. Only works when we are dividing by a linear binomial with a leading coefficient of 1. Linear, remember, means our highest power is just 1. Binomial, two terms, we've got an addition problem in the middle. Leading coefficient of 1, I see a 1 before the x squared over there. Take a moment, turn to page 26. Look at what you're dividing by in every single problem. X minus 1, x minus 4, x plus 5, x plus 4. Linear binomials with a leading coefficient of 1. I want to start this the same way I started long division. I want you not to write a single thing down, and I just want you to watch me do an entire problem. Then we're going to go and redo the problem, taking notes. But I do want you to see the entire process. It's going to seem very strange. It's going to seem complicated. Please just give me a chance. I promise by the time we're done with this stuff, you will be able to do division problems very quickly, and you will find this method easier than long division. So I'd like to take a look at this division problem. X cubed plus 6x squared plus 5x minus 12 divided by x plus 3. The first thing I'm going to do, and again, do not write a single thing down, just watch. The first thing I'm going to do, and I'm going to set x plus 3 equal to 0. I'm going to take the thing you're dividing by and set it equal to 0. I'm going to solve that little equation. No, I don't necessarily have to see this work. And I'm going to get negative 3. I'm going to write a negative 3, and I'm going to put it in a little half box, like that. The next thing I'm going to do is I'm going to look at the problem, and I'm going to write out my coefficients. 1, 6, 5, negative 12. 1, 6, 5, negative 12. I'm going to leave a space, and I'm going to draw a horizontal line. And this is the setup for my synthetic division. I'm just trying to show you that's not part of anything. This is the setup for my synthetic division. Here's how the process now works. This first number, I'm just going to bring it straight down here into the answer. Diagonally, I'm going to bring up this number times what was in my little half box. I'm going to bring up 1 times negative 3, and I'm going to get negative 3. Coming down, I'm going to add these two things together. 6 minus 3 gives me 3. Diagonally, I'm going to bring up this answer times what was in the box. 3 times negative 3 is negative 9. And then I'll add 5 minus 9, negative 4. Diagonally, I'm going to bring up negative 4 times negative 3. I'm going to get 12. I'm going to add, and I'm going to bring down the answer. These numbers tell me information about the answer. The answer is going to be a polynomial with degree 1 less than what we started with. I started with a cubic function, So my answer is going to be a quadratic function, and these are going to be the coefficients. My answer is going to be 1x squared plus 3x minus 4, and if I had a number over here, that would be my remainder. This is synthetic division. I know this seems strange. Stick with me, and I promise by the time we're done with examples on this, you will find this a lot quicker and a lot easier than long division. We're going to do that problem again. I want to divide this thing by this, and this time I do want you writing all this down. The first thing I'm going to do is I'm going to take the thing I was dividing by, and I'm going to set that equal to 0. I'm going to set x plus 3 equal to 0, which of course gives me x equals negative 3. What am I going to do with that? I'm going to take that little number and put it in a half box. I'm going to put that number in a half box. Negative 3, right over there, in my little half box. Why a half box rather than a full box? I got nothing. I don't know. Step number 2. I'm going to go and I'm going to list my coefficients. One, 6, 5, negative 12. I'm going to go and list them. By the way, if you're missing a term, just like we saw when we were missing terms with long division, we still need to include a space for it. So here, if you're missing a term, we'll just include a 0. If you're missing a term, we're going to include a 0. We'll see some of those in a moment. I'm going to leave a space. I'm going to draw a horizontal line. And I have my setup ready to go. Step 3. I'm going to bring down my first coefficient. Bring down the first coefficient. By that, I mean vertically. I'll just bring down a 1 over there. Diagonally. And diagonally, up in this direction, I will bring up your last number times what's in the box. Bring up your last number times what's in the box. Step number 4, diagonally, I'm going to bring up the last number times what's in the box. Which means I'm going to go do the problem 1, my answer, times negative 3, which was in the box, and I'm going to get a negative 3. I'm going to go and add vertically those two numbers. Number 5, add vertically the two numbers, which means I need to do the problem 6 plus negative 3, or 6 minus 3, and I'm going to get 3. Step number 6. I'm going to continue repeating this process. I'm going to repeat step 4 and 5. Which means I'm going to bring up diagonally this answer 3 times what was in the box. I'm going to bring up 3 times negative 3, which means I'm going to bring up a negative 9. I'm going to add 5 minus 9, I'll get -4. Diagonally, I'm going to bring up that number times what was in the box, -4 times -3, and I'm going to get 12. I'm going to bring down a 0. Final thing I need to do is just interpret the answer. The answer will be a polynomial with degree 1 less than what you started from. The answer is a polynomial with degree 1 less than what you started from. And coefficients from that bottom line. The answer is a polynomial with degree 1 less than what you started from, and coefficients from that bottom line. I started from a cubic, my answer is a quadratic. My answer is going to be 1x squared plus 3x minus 4, and if this was a number, it would be my remainder. I'll make the video pause so you can finish getting any of those notes. Okay, so we're going to take a look at a few examples. Letter A on the top of the next page. First thing we need to do, look at the thing we're dividing by. X minus 1, I'm going to set it equal to 0. Well, what's x going to equal? And we're going to stick that in our little half box. I hope you're saying x equals 1. That's going in my box. I'm going to go list my coefficients. 1, 3, -1, -3. Here we go. I'm going to bring down a 1. Diagonally, I'm going to bring up the answer times what was in the box. 1 times 1 will give me 1. I'm going to add. 3 plus 1 gives me 4. I'm going to multiply this answer times what was in the box. 4 times 1 gives me 4. I'm going to add. I've got a 3 over there. Diagonally, I'm going to bring up the answer times what's in the box. 3 times 1 gives me 3. Answer is 0. My original problem was a cubic. My answer needs to be a quadratic, degree 1 less, and these are the coefficients. So 1x squared, no, you can just say x squared, that's totally fine, plus 4x plus 3 is my answer. I'd like you to take a look at B and see if you can do the setup. See if you can figure out what's going in the half box, list your coefficients, and then stop. What would make x minus 4 equal 0? Well, a 4. And I hope your coefficients looked like that. We're going to divide this together. You're going to help me. I'm going to bring down a 5. I'm going to bring up that answer times what's in the box. So what number am I bringing up? 5 times 4 gives me 20. I'm going to add these numbers together. What number am I bringing down? -6 plus 20 should give me 14. I'm going to bring up that number times what's in the box. What's going to go up? 14 times 4 should be 56. What am I bringing down? Add those numbers together. 4 plus 56 is 60. I'm going to bring up what? 60 times 4 is 240. I'm going to bring down 239. My answer, I started from a cubic. My answer needs to be a quadratic. 5x squared plus 14x plus 60. My remainder will be over x minus 4. So I'm going to say plus 239 over x minus 4, the same way we wrote remainders when we did long division. Go do your setup for C. We'll check to make sure that's right, and then you'll go from there. Try the setup for C. X plus 5, you're going to set that equal to 0, and you're going to put negative 5 in the box. If you wrote out your little equation, x plus 5 equals 0, minus 5, yeah, you're getting x equals negative 5. Your setup should be a 2, a 3, a negative 32, an 8, and a negative 30. How about you see if you can do this? I'm going to bring down a 2. I'm going to bring up a 2 times negative 5, negative 10. Add 3 times negative 10 is negative 7. I'm going to bring up negative 7 times negative 5, 35. Negative 32 plus 35 is 3. I'm going to bring up 3 times negative 5, negative 15. Add 8 minus 15 is negative 7. Bring up negative 7 times negative 5, positive 35. Bring down 5. Your answer should be 2x cubed, because you started from a quartic. I'm going to get a cubic. Minus 7x squared plus 3x minus 7 plus 5 over x plus 5. This is synthetic division. Do your setup for D and then stop. Be a little careful. Negative 4 in the box. I hope you noticed we were missing an x squared term, which means when I write out my coefficients, I need a 1 for the x cubed, but then a 0 for the x squared, a negative 13 for the x, and a 12 for the constant. If you didn't get that 0 in there, go put it in there. Then go do your synthetic division and send your answer into Edpuzzle, please. Down 1, up negative 4, down negative 4, up negative 4 times negative 4, 16, down 3, up negative 12, down 0. I hope you sent in x squared minus 4x plus 3. Last synthetic division problem, then there's one other topic we'll look at in this section. Letter E. Do your setup and stop. Be careful. No, I take that back. Don't be careful. Be super careful in E. I bet I caught some of you here. We should have a 2 in the box. 1x to the 5th. Then we need a 0 for the x to the 4th. You probably got that. Then a negative 3 for the x cubed. Then I need a 0 for the x squared term, but also a 0 for the x term. There should be a total of 3 zeros in your setup here. If you don't have those, go get them in there. Otherwise, go do your division, and we'll see what happens. Okay, here we go. I think this problem would have taken a pretty long time by long division, but I bet synthetic I can get this done in about 15 to 20 seconds. Here we go. Down 1. Up 1 times 2, 2. Down 2. Up 2 times 2, 4. Down negative 3 times 4, 1. Up 1 times 2, 2. Down 0 plus 2, 2. Up 2 times 2 is 4. Down 0 plus 4 is 4. Up 4 times 2 is 8. Down 4 plus 8 is 12. X to the 4th plus 2x cubed minus 1x squared plus 2x plus 4 plus 12 over x minus 2. And that is your answer. And this is synthetic division. I'll make the video pause if there's anything you need to catch up on from this page. I think it's probably time for me to get a new pen. It looks like that's about out of ink. We'll see if there's any ink left in the black pen. And there's one other thing we have to talk about in here, and this is called synthetic substitution. Actually, there are two different types of substitution we're going to look at. One that you already know, you've been doing this since Algebra 1, but we definitely reviewed this at the beginning of the year, called direct substitution. I didn't call it that, but that's what it was. And we're only going to talk about this as a way to compare our new synthetic substitution to something. First of all, direct substitution, that involves evaluating a function by plugging in a number. Direct substitution is evaluating a function by plugging in a number. Direct substitution is evaluating a function by plugging in a number. So, this example over here, p of x is this function over here. Use direct substitution to find p of 4. This is what we did in the beginning of the year. P of 4 is just going to equal 4 to the 4th minus 5 times 4 squared plus 4 times 4 plus 12. And you're probably going to need a calculator. 4 to the 4th is going to give you 256 minus 16 times 5 minus 80 plus 16 plus 12. Well, 256 minus 80 is 176 plus 16 plus 12. 176 plus 16 is 192, I believe. Plus 12, I think, should give you 204. A little bit of a pain to deal with by hand. The numbers are a little unpleasant. But this is direct substitution. This is not what you're going to be doing in your homework. You're going to be using a new method of kind of plugging in that's actually going to let us deal with smaller numbers and may let us deal with this stuff easier, especially if we don't have a calculator, called synthetic substitution. And I'm just going to define synthetic substitution as evaluating a function by somehow making use of synthetic division, and I'll give you more specifics in a moment. Evaluating a function by making use of synthetic division. By making use of synthetic division. Synthetic substitution, evaluating a function by making use of synthetic division, somehow. Get this in your notes. Before I show you an example of that, we need this theorem called the Remainder Theorem. What the Remainder Theorem says is if we take a polynomial function p of x, given a polynomial function p of x, p of a is the same as the value of the remainder
Please excuse the interruption. At this time, we would like to dismiss all student drivers and their passengers. Again, all student drivers and their passengers are dismissed at this time.
p of a is the same as the value of the remainder when dividing p of x by x minus a. Just copy it down. I'll show you exactly what this means for us in a moment. That's our remainder theorem. So, I want to take this function, find p of 4, and I want to try to do it with this new synthetic substitution method I haven't even explained to you yet. I already know what the answer should be. It should be 204 because it's the exact same problem I did up here. But here's our new synthetic substitution method. First thing we're going to do, we're going to divide our polynomial function p of x by x minus 4. I'm going to divide p of x by x minus 4 using synthetic division. Now, where did I get x minus 4 from? Sort of from my remainder theorem. P of a is the same as the remainder when I divide by x minus a. P of 4, I want to divide by x minus 4. Basically, p of whatever, I want to divide by x minus that thing. If you're dividing by x minus 4, you're going to stick a 4 in your box. I'm going to go list out my coefficients. 1, notice there isn't an x cubed term, so 0, -5, 4, and 12. I'm going to go do my normal synthetic division that we just got pretty good at. Down 1, up 4, down 4, up 16, down 11, up 44, down 48, up, here I'm going to go to my calculator just to be safe. 48 times 4 is 192, down 204. Oh my goodness. That remainder, it's the same thing we got when we plugged in directly. That's what our remainder theorem tells us. This remainder is the value of p of 4. P of 4 is the value of the remainder. This problem asked you to find p of 4 by synthetic substitution. P of 4 is just the number 204, which is the same number I would have gotten if I plugged in 4 directly, but this is another way to do it, and we're going to see this will be particularly useful with certain types of equations that will be coming soon. P of 4 is 204. Also notice my answer is not a polynomial. It wasn't a synthetic division problem. It was a synthetic substitution problem. I'm going to show you 2 more examples and we'll be set. Make sure this is in your notes. Letter A on the next page. P of x equals x cubed plus 4x squared plus 6. Find P of 2. Well, P of 2 means you're dividing by x minus 2, which means we're going to stick a 2 in the box. And honestly, with this synthetic substitution stuff, P of whatever number that is, that number as it is will just go in your box. Set up your synthetic division. Don't do it yet. I hope you noticed we were missing an x term, so I'm going to say 1, 4, 0, 6. You're going to now go do your synthetic division, and your answer is not going to be a polynomial, it's just going to be a number, whatever number you end up with for your remainder. Tell me what P of 2 is by synthetic substitution and send that into Edpuzzle. Down 1, up 2, down 6, up 12, down 12, up 24, down 30. P of 2 is 30. This is synthetic substitution. Go do letter B on your own and send your answer into Edpuzzle. Here we go, -2 in the box. List the coefficients. 2, 6, -5, don't have an x, so 0, -60. And we're off. Down 2, up -4, down 2, up -4, down -9, up 18, down 18, up -36, down -96. P of -2, -96. In the homework, make sure where it says use synthetic substitution, you are using synthetic substitution. You will not get credit for that part of the homework if you're using direct substitution and just plugging in your number like we would have done in Unit 1. Also make sure for the synthetic substitution problems, your answer is just a single number, as opposed to the synthetic division problems, where your answer, this divided by this, is an entire polynomial. Thursday and Friday, we'll look at some applications of this division, how we can use this division to solve some equations and do a little bit of factoring.